You ever get that feeling that there's some kind of hidden code running the world around us? A secret language that's behind everything, from how your money grows to the rhythm of your favorite song? Well, guess what? There is. And the best part is, you already have the key to unlock it all.
Yeah, I know. It sounds like some kind of brain teaser, right? But seriously, just think about it for a second. What on earth could possibly connect the pixels on your phone, the massive growth of the human population, and the slow, steady ride on a Ferris wheel?
So, the answer? It's math. But hold on, don't tune out. We're not talking about dusty old textbooks here. I want you to think of math as this incredibly powerful, super practical toolkit. And right now, we're going to open that toolkit up and look at 4 essential tools that'll help us describe, predict, and really understand the world. Let's start with the first one. All right, so the first tool we're going to pull out of this kit, it's maybe the simplest one, but honestly, it's also one of the most powerful. This is the tool for drawing a perfectly straight line from a problem to its solution. It's the blueprint for any predictable change. Okay, let's make this real. You've got a goal, that $2,500. You've got a starting point, the $400 you've already saved. And you've got a steady, constant way of getting there, $15 an hour. This is super straightforward, right? No curveballs, no sudden plot twists. For every single hour you work, your savings go up by the exact same amount. So how do we build a blueprint for that? So, for this job, we grab a tool called a linear function. And the key phrase you got to remember here is constant rate of change. That's the secret sauce. If something is changing steadily, predictably, without any surprises, this is the tool you reach for every single time. And this right here, this is basically the instruction manual for the tool. Let's break it down real quick. The Y is your goal, the total money you'll have. That's made up of M, your hourly wage, multiplied by X, the number of hours you work. And then you just add B, the cash you already started with. See? It's simple, it's clean, and it's an incredibly effective blueprint. And this is what's so cool when you see it visually. That formula doesn't just spit out a number, it draws a perfectly straight line. It's a direct path from where you are to where you want to be. So the big takeaway here is linear functions are our blueprints for a predictable world. But the world isn't always a straight line, is it, right? Life loves to throw us curves. Sometimes we need to model areas, arcs, and more complex spaces. For that, we need to dig a little deeper into our toolkit for something more flexible, our building blocks. So picture this. A developer is planning a house on some land. The dimensions aren't just simple numbers, they're variables that can change. See, the area isn't just a simple line anymore. It's a whole two-dimensional space that needs a different kind of calculation. The tools for this job are called polynomials. We call them our building blocks. Yeah, they look a little more complicated, but that's exactly what gives them their power. They're like the Legos of mathematics, letting us combine variables and different powers to build models for all sorts of physical things. Now, this might look a little intimidating, but just think of it like a recipe. Each one of these parts, the x squared, and so on, is a different kind of building block. One might create a slope, another adds a curve, another could add a little wiggle. You just mix and match them, adding them together until you've built the exact shape you need. And wow, look at this. This shows you exactly what those blocks can build. This beautiful arc, a parabola, is made by a polynomial. And it's the very same shape that describes the path of a basketball going for a hoop or the design of a satellite dish. By using these mathematical building blocks, we can precisely describe the curves of our world. All right, you ready? Because our next tool, this is where things get wild. This is the one that lets us model stuff that doesn't just grow, it explodes. This tool lets us kind of travel through time and predict the future. Just think about something like population growth. It's not a steady, linear thing. The growth itself grows because more people lead to even more people. It's a compounding process, a feedback loop. So how in the world do you model something that's constantly speeding up? For that, you need a totally different tool, the exponential function. The real magic trick here is that the variable, in this case time, is actually in the exponent. That's what creates this crazy feedback loop, where the output gets multiplied over and over and over again, leading to that rapid acceleration. And this little formula? This is the engine that drives it all. A is your starting amount, the initial population. B is the growth factor, and the magic is that X, the amount of time that's passed, is up there in the exponent. That's what creates the compounding effect. It's basically the mathematical formula for a snowball rolling down a hill, getting bigger and bigger, faster and faster. Okay, get ready for the aha moment, because this graph says it all. Just look at how that orange exponential curve starts off slow, but then completely leaves the steady blue line in the dust. For a little while, they look kind of similar, but then the power of compounding just takes over. That right there is why this tool is so crucial for understanding everything from your investments to how a virus spreads. Okay, time for our last tool. And this is a master key. It's for understanding a huge part of our universe, rhythm. So much of our world, from sound waves to the changing seasons to the orbits of planets, it all works in repeating cycles. And this tool gives us the language to describe that repetition. Let's use a classic example, the London Eye. Think about a rider on it. Their height doesn't just grow forever, right? It goes up, then it comes down, then it goes back up again in this perfectly predictable repeating pattern. It's a cycle. It has a rhythm. And the tool for that rhythm? It's trigonometry. Now forget those triangles you had to memorize in school. At their core, trigonometric functions like sine and cosine are just the mathematical description of waves and cycles. They are the language of rhythm. That's it. And look at this. Isn't that amazing? You can take the real-world physical movement of that giant steel wheel and translate it into this elegant, smooth, flowing wave. The peak of the wave is the top of the ride. The bottom of the wave is, well, the bottom. And one full wave is the time it takes for one rotation. It is a perfect model. So, there you have it. We've just unboxed 4 super powerful tools from Math's Secret Toolkit. And these aren't just for tests, you know? They're like putting on a new pair of glasses that lets you see the world in a whole new way. So let's recap what's in your new toolkit. You've got your blueprints for any steady progress. You've got your building blocks for physical shapes and curves. You've got a time travel device for predicting rapid change. And you now have the ability to find the rhythm in the cycles all around you. You can now see the hidden structure where most people just see randomness. So you've been given the tools. You can see the blueprints, the building blocks, the flow of time, and the rhythm of the universe. The only question left is, now that you can see the code, what new patterns will you